Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
The ground on the north rim of the Yellowstone Caldera is rising again.
In July 2025, the ground beneath Yellowstone National Park started moving, not shaking, moving, slowly, quietly, and in a place that had not moved like this in over 20 years. A section of the North Caldera Rim, the edge of the ancient supervolcano, began to lift. GPS stations detected it, satellites confirmed it, and then in November 2025, a swarm of over 100 earthquakes hit directly on top of the center of that uplift. The largest was a magnitude 2.7, and scientists were watching every single one of them. In February 2026, a geyser in Norris Geyser Basin erupted 40 times in a single month. It had been mostly quiet for years. Yellowstone is not erupting. The official alert level is normal. The USGS has been clear about that. But what happened between July 2025 and early 2026 is one of the most interesting episodes of ground movement and seismic activity this system has produced in decades. And it revealed something important about what is happening miles beneath America's most famous national park. This video is going to tell you exactly what moved, why it moved, what the scientists found when they looked deeper, and what it means for the 5 million Americans who live inside the wider danger zone of this volcanic system. Most people think of Yellowstone as a park. Geysers, hot springs, bison, tourists with cameras, that picture is real. But underneath it is something that has no equal anywhere in North America. Yellowstone sits on top of one of the largest and most powerful volcanic systems on Earth. Not just a volcano. A volcanic system, a vast network of magma chambers, fractured rock, hydrothermal water, and heat that extends dozens of miles beneath the surface of Wyoming, Montana, and Idaho. The caldera itself, the ancient collapsed crater, is 45 miles long and 28 miles wide. The whole park fits inside it. When you drive through Yellowstone, you are driving across the floor of a volcano. That volcano has produced 3 massive eruptions in the last 2.1 million years. The largest, 2.1 million years ago, ejected 450 cubic kilometers of material, one of the biggest eruptions in Earth's known history. The most recent caldera-forming eruption, 640,000 years ago, buried much of what is now the western United States under layers of ash. Those eruptions are not happening again tomorrow. USGS scientists have been explicit on this point. There are no signs of magma approaching the surface, no signs of imminent eruption. The system is active, not critical. But here is why Yellowstone demands attention even when it is not exploding. It is always doing something. The ground rises and falls. Geysers start and stop. Earthquakes rattle through the rock. Thermal areas shift and change. The system is alive in a way that most geological features simply are not. Yellowstone averages between 1,500 and 2,500 earthquakes every year. It has 46 seismometers, 26 GPS stations, and multiple satellite passes every single day monitoring it continuously. That level of monitoring exists for one reason. The system is powerful enough that even its normal behavior, the background activity that scientists call routine, is worth watching every day. And in 2025, the background activity stopped being entirely routine. In July 2025, GPS stations at 2 monitoring sites, one near Madison Junction, one near Norris Junction, began recording something unusual. The ground between them was pushing outward, not dramatically, not visibly. We are talking about a centimeter of movement over several months. But both stations were moving away from each other, which meant something in the center was inflating. USGS scientists identified the location. It was on the north rim of the Yellowstone Caldera, just south of Norris Geyser Basin. A specific zone they call the Norris Uplift Anomaly, because this exact same patch of ground did the same thing between 1996 and 2004. It lifted, then settled, then went quiet for years, and now in 2025 it was lifting again. Satellite radar data confirmed it. The surface in this zone had risen slightly, detected not just by GPS but by INSAR, a technique that compares radar images of the same patch of ground taken weeks apart and measures movement to the millimeter. USGS scientists determined the source was roughly 14 kilometers, about 9 miles beneath the surface. Not the main magma chamber, something deeper, likely hydrothermal fluids or gases moving through fractured rock in response to activity that far down. Then in November 2025, over 100 earthquakes clustered directly on top of that uplift zone. The largest was magnitude 2.7, small earthquakes by any normal measure. But the location sitting right on the center of the uplift meant scientists were watching very carefully. Was this the start of a new phase of caldera uplift? USGS scientist in charge Michael Poland asked that question directly in a published Caldera Chronicles article in January 2026. Was this like the uplift episodes of 2004 to 2009 and 2014 to 2015? A multi-year shift in how the ground was behaving. The answer, as of early 2026, is that the uplift stopped. By mid-January 2026, the movement had ceased, the ground settled, but what it revealed while it was moving tells you something important about this system. If the uplift zone is where scientists detected the movement underground, Norris Geyser Basin is where you can actually see Yellowstone's energy at the surface. Norris is the hottest thermal area in Yellowstone. Not just warm, genuinely extreme. Water temperatures in some of the pools here exceed boiling point at the surface. The soil is acidic. Steam vents hiss constantly. The boardwalks run through a landscape that looks like the ground is actively trying to escape from below. It sits right at the edge of the caldera rim, which is exactly why it is so sensitive to changes in what is happening underground. When fluids shift, when pressure builds or releases, when something moves at depth, Norris is often where the surface reacts first. That is why what happened at Aquinas Geyser got attention. Aquinas Geyser is one of the largest acid water geysers in the world. For years it erupted regularly, then fell into irregular and infrequent activity. In February 2026, right at the tail end of the uplift episode, it erupted 40 times in a single month. That is not a record. But it is unusual enough that USGS logged it and scientists noted the timing. By March, it was down to one eruption for the entire month. By May 2026, 2 eruptions. The spike was short, but the timing. Sitting right at the end of a 6-month uplift episode in the zone directly south of Norris is the kind of connection scientists pay attention to. There was also an eruption at Black Diamond Pool in Biscuit Basin on March 9, 2026. Detected by acoustic, seismic, and temperature sensors. Biscuit Basin had a hydrothermal explosion in 2024, the first instrumentally detected hydrothermal explosion in the Yellowstone region in the modern monitoring era. This is what Yellowstone's normal looks like right now: geysers waking up, thermal pools exploding, ground rising and falling, earthquakes clustering on fresh deformation zones. Not a crisis, but not quiet either. When most people think about Yellowstone danger, they think about one thing: the supervolcano, the Hollywood ending, the caldera-forming eruption that buries the continent. That is the least likely scenario. USGS has said explicitly that scientists are not even convinced another eruption of that scale will ever happen. The real dangers are smaller, more immediate, and more likely. The first is hydrothermal explosions. These happen when underground water superheated by the volcanic system suddenly flashes to steam. The pressure has nowhere to go. The ground above it blows. These are not rare events in Yellowstone's history. They have happened dozens of times over the last 14,000 years, creating craters across the park. The explosion at Biscuit Basin in April 2024 was small enough that it caused no injuries. A larger one in a populated visitor area would be a different story entirely. The second is earthquakes. Yellowstone sits on a complex fault system. The largest recorded earthquake in the region was magnitude 7.3, the 1959 Hebgen Lake event that killed 28 people and reshaped the landscape. A quake of that scale originating near the park today would cause immediate damage to roads, buildings, and park infrastructure, and would affect communities across 3 states. The third is toxic gases. The hydrothermal system produces carbon dioxide, hydrogen sulfide, and other volcanic gases. These accumulate in low-lying areas. There have been documented animal kills in Yellowstone from gas accumulation. In a crisis scenario involving larger gas emissions, the hazard zone extends well beyond the thermal areas. And then there is ashfall, not from a supervolcano. From a smaller lava flow or explosive eruption, the kind Yellowstone is more realistically capable of producing. Even a modest ash cloud disrupting regional air travel, agriculture, and water systems in Wyoming, Montana. None of these require a caldera-forming eruption. They require Yellowstone to do what it has always done, just a little more than usual. 5 million Americans in the danger zone does not mean 5 million people standing inside the caldera. It means 5 million people living close enough to Yellowstone that a real volcanic crisis, not necessarily a supereruption. Here is what danger means at different distances. Within 20 miles of the caldera, direct hazards are extreme in any serious eruption scenario. Pyroclastic flows. Ground rupture, toxic gas, immediate evacuation. No civilian population survives at ground zero. Between 20 and 50 miles, ashfall becomes the primary hazard. heavy enough to collapse roofs, contaminate water supplies, shut down engines, ground aircraft, and make roads impassable. Agriculture in this zone could face season-ending losses even from a moderate event. Beyond 50 miles, the hazard profile shifts to respiratory risk from fine ash particles, disrupted supply chains, grounded aviation, and economic shock from tourism and agriculture collapse. This zone includes Billings, Montana, Boise, Idaho. Salt Lake City, Utah is about 300 miles south. Denver, Colorado is 500 miles away. Ash from Yellowstone's largest historical eruptions has been found in soil samples as far away as the Gulf Coast. In a significant but not catastrophic eruption, the kind scientists describe as the more realistic scenario, the impact zone is not the whole country, but it is a significant region. And the communities inside that region have emergency plans, monitoring systems, and evacuation routes specifically because of Yellowstone. That is not panic. That is what preparedness looks like for a geological system this powerful. Yellowstone has the most advanced volcanic monitoring network in the United States, possibly in the world for a system of this type. 46 seismometers track ground shaking continuously. 26 GPS stations measure surface movement to within millimeters. Multiple satellite passes every day use INSAR radar to detect deformation across the entire region. Sensors measure carbon dioxide and hydrogen sulfide gas emissions at key thermal areas. Water temperature and chemistry in thermal pools is tracked. Geyser eruptions are timed and logged. All of this data flows to the Yellowstone Volcano Observatory, a joint operation involving USGS, University of Utah, National Park Service, and other partners. Scientists review the data daily. Monthly updates are published publicly. Any significant change in activity triggers an immediate assessment. This matters for one specific reason. If Yellowstone were actually building toward a major eruption, the warning signs would be detectable years in advance. A precursory swarm for a large eruption would not look like 100 small earthquakes over a few months. It would involve sustained escalating magnitudes, magnitude 4 and above, persistently over months. Rapid ground uplift measured in meters, not centimeters. Dramatic changes in gas chemistry, heat flow anomalies visible from satellite, multiple signals converging simultaneously. None of those signals are present now. The current alert level is normal, green aviation code. Background seismicity. What the monitoring network told scientists about the 2025 uplift episode is that it was driven by fluid and gas movement about 9 miles beneath the surface, not magma approaching from below, but dynamic activity in the deep hydrothermal system responding to something even further down. That is genuinely interesting to scientists studying how volcanic systems work. It is not a precursor to an eruption, but it is exactly the kind of thing you only learn about by watching constantly. Here is the question viewers are always asking underneath the surface of a Yellowstone video. How would we actually know if something was really wrong? The answer is specific and public. USGS uses a 4-level alert system for volcanoes. Normal means background activity. Advisory means elevated unrest above background worth watching. Watch means increased potential for eruption or minor eruption underway. Warning means hazardous eruption imminent or already happening. Yellowstone has been at normal for its entire monitored history. It has never reached advisory. When you see a Yellowstone headline online and want to know if it is real, the fastest fact check is a 30-second visit to the USGS Yellowstone Volcano Observatory website. If the alert level has not changed, the story is either background activity being dramatized or an outright fabrication. What would actually move the alert level? A sustained swarm of large earthquakes, magnitude 4 and above, running continuously for days or weeks, not hours. Ground uplift measurable in meters over short periods, not centimeters over months. Dramatic changes in gas emissions, a sudden spike in sulfur dioxide which comes from magma, not just hydrothermal water. Multiple monitoring systems showing converging signals simultaneously. New thermal features opening up rapidly in areas where there were none. Any one of these individually could be explained by normal volcanic system dynamics. Multiple signals together, escalating over time, would trigger an alert level change. That has not happened. It did not happen during the 2025 uplift. Scientists looked at every data stream. The signals pointed to deep hydrothermal movement, not magma approach. But here is the honest statement underneath all of this. The system that produced the largest eruptions in North American geological history is still active, still moving, still generating heat that drives geysers, shifts ground, shakes the earth, and occasionally causes parts of the surface to explode without warning. Normal for Yellowstone is not the same as safe. It is just not an emergency. Between July 2025 and January 2026, a section of the Yellowstone Caldera rim lifted. An earthquake swarm hit the exact center of that uplift. A geyser that had been quiet for years erupted 40 times in a month. And scientists spent 6 months analyzing what was happening 9 miles underground. Their conclusion was not alarming. The movement stopped. The system settled back to background levels. No alert level change, no escalation. But here is what that episode actually showed. Yellowstone is not a static geological feature waiting to become dangerous. It is a dynamic living system that is constantly doing something. The monitoring network that exists around it, the seismometers, the GPS stations, the satellites, the gas sensors, exists because the system demands that level of attention. 5 million Americans live close enough to feel the consequences of a serious escalation, not because an eruption is coming, but because Yellowstone has always been capable of events that do not require a supereruption to be genuinely dangerous. Hydrothermal explosions, major earthquakes, toxic gas events, regional ashfall from smaller eruptions, all of these are realistic. All of these have happened in Yellowstone's recent geological history. And all of them would be detected early because of the monitoring network that watches this system every single day. That is the real Yellowstone story, not the Hollywood version where the caldera explodes without warning. The real version where one of Earth's most powerful geological systems is alive, active, and watched more carefully than almost anything else on the continent. It is not erupting today, but it moved in 2025. It shook in November. It lit up again in February. And the scientists who watch it every day will be the first to tell you, understanding what Yellowstone is doing between eruptions is exactly how you know when to take it seriously.